Alright, so today we're going to start chapter 10, which is about a lot of things: quadratic equations, quadratic functions, quadratic inequalities, and algebra of functions. Algebra of functions. The first two sections are a review mostly from beginning algebra, but the rest of the stuff is totally new for you. Okay, so 10.1 we're going to review quadratic equations. We're gonna review factoring first. But first let's talk about what a quadratic equation. So a quadratic equation is of the form quadratic equation in general form. It's called general or standard form. Okay, can be written as ax squared plus bx plus c equals 0. So we've seen a lot of quadratic equations where a, b, and c are real numbers. A cannot be 0, b and c could be anything, because if a were to be 0, then we get linear equation. Okay, if b is 0, we still have quadratic. If c is 0, we still have quadratic because you have x squared, but a cannot be 0, and these are all real numbers. There are 4 methods for solving quadratic equations, 4 methods, and actually have handout on each method. Okay, like here, handout, it's in your class notes, all these methods. Okay, so make sure you review the handout with some examples. The first method is the factoring, which we are very familiar with. I'll just give you examples. The steps are in the handout. Factoring method. So for example, solve by factoring. Like I said, we've done a lot of this before, but it doesn't hurt to review one. X squared plus 2x equals 35. The first thing we want to do is set it to 0. And then factor the trinomial. Product is of negative 35, sum of 2, so negative 7 and 5. Each factor equals 0 by the 0 factor property, so we got 2 solutions in this case. Okay, so it's the easiest method. It can only be used though if the expression is factorable, and we've done a lot of this. The second method, which is called the square root method, which may be used if there is no middle term. If you look at the quadratic equation and it doesn't have the middle term, if it has x squared and c constant. So what you're going to do to solve by the square root method, you're going to separate, so you're going to isolate the square term. So you're going to get squared. It doesn't have to be x, it could be x plus 1, 2x minus 1 equals c, and then square root both sides. And then solve. Okay, so isolate, square root, and then solve. And again, this is restrictive because you can only do it if you have no middle term. If you have a square term and a constant. A square term and a constant. So no middle term, basically. So for example, if we have 2x squared minus 128 equals 0, so there's no middle term, so we can do square rooting by isolating x squared, moving the 128 and then dividing the 2, that's 64 square root. And when you square root both sides, to get both answers you're going to do plus or minus, so x equals plus or minus 8. Number 20, page 836. U squared minus 24 equals 0. Isolate u squared, square root it, so u is plus or minus root 24, which is root 4 times root 6. Now we know how to simplify the radicals, so we always have to do that. And another one, 3x squared minus 225 equals 0. So move the 225 over, divide by 3. What's 225 divided by 3? It's 75 square rooted, plus or minus root 25 times root 3, which is 5 root 3. And it's plus or minus. Two solutions. Okay. Now if you have x minus 5 squared minus 11 equals 0. Okay, it would be a big mistake if you foil this. If you foil it, look what's going to happen. I know some of you probably want to do that. So you get x squared minus 10x plus 25 minus 11. The problem with this is now you have to factor, and this doesn't factor. Okay? Product of 14, sum of negative 10. Good luck. So it would be a big, even if you did it, you should realize this is the wrong way once you get to non-factorable expression. You already have a square and a constant, so isolate the square by adding the 11. And square root, it's set up for you to do square rooting, so do it. X minus 5 is plus or minus root 11. Do anything with root 11, so we leave it as is. So you get two solutions, and they are irrational because you're stuck with the square root. You have 5 plus root 11 and 5 minus root 11. That's why you couldn't factor it. Okay? Here's another one. X plus 3 squared minus 7 equals 0. So isolate the square term. Square rooted, add plus and minus. X plus root is plus or minus root 7. And just like the previous example, we get two irrational solutions. Negative 3 plus root 7 and negative 3 minus root 7. Okay, now let's look at number 28 from page 836. 9n squared plus 121 equals 0. Again, this is a good candidate for square rooting because there is no middle term, no n. So isolate n squared by moving the 121 over and dividing the 9. So n squared is negative 121 over 9. Square rooting with a plus or minus. So now we have a negative inside the square root, so we know that's going to be I root 121 over 9. And we get two imaginary solutions, plus 11 over 3i and minus 11 over 3i. And here's another one. 16x squared plus 25 equals 0. Again, there is no middle term. So we're going to move the 25 over, divide the 16, square root it. X equals plus or minus I root 25 over 16. That's 5 over 4, so 5 over 4i, again, two imaginary solutions. So we can use factoring when it's factorable. We can use square rooting when there is no middle term. Now what if I have to do something like this, x squared plus 4x plus 2 to solve the equation? A product of 2 is sum 4. Good luck finding these two numbers. And we cannot do no factoring, no square rooting will work, so that's the need for what we call completing the square. The third method, completing the square, which will solve any quadratic equation. It doesn't have to be factorable, it doesn't have to have no middle term, it will solve any quadratic equation. The idea is this. There's a problem with the 2. That 2 doesn't belong there because a product of 2 and a sum of 4 is not achievable, so we're going to remove the 2 first. So remove the 2 by moving it over and make sure that it's a 1. If it's not a 1, divide by the leading coefficients. Again, the steps, I'm not going to write them down because they're all in the handout, okay, that I told you about. Okay, right here. Completing the square. So I'm just going to go over those steps as I'm doing the problems, but you are welcome to put the steps next to you while you're listening to the videos, okay, so you can see what's going over. So The first thing you want to do a constant, because that's no good. We need a number here. So what we're going to do, we need a number here, to add a number here, so that when we have a number there, this is going to factor into a perfect square, and then you're going to have a constant there. It's not going to be -2 because we're going to add something to it. Once we get to this point, then we're going to do square rooting, okay? Method number 2. How do we get from this to that? That's called completing the square. That is completing the square. Completing the square. So what's the idea? Okay, move the constant over, divide by the leading coefficient if it's 1. If this was a 2, we divide everything by 2. If it's a negative, we divide everything by -1. You have to have a 1 in front of x squared before you proceed. So the number that we're going to add to both sides of the equation. Okay, we only need it on the side, but we want to keep the balance of the equation. How do we find that number? It's you're taking whatever number in x, okay, divided by 2. So 4 divided by 2 is 2, and then whatever number you get, you square it. Okay, that's why it's called completing the square. So you take the coefficient of x, which is a b actually, divided by 2, you get 2, and then you square it. So steps, you divide by 2 and then square your answer. You get 4, and then you add that number to both sides of the equation. Okay, divide by 2 and square your answer. Once you get to that point, then it's definitely going to be this. If you look at factoring, now it's a product of 4 instead of 2 and sum of 4. So it's 2 and 2, and it's always going to work out where it's perfect square. And the trick is, it's always going to be an x here. You drop the sign, and then whatever number you squared is going to go in here, 2 square. If this was 3 square, you have 3 square. If you have 1/2 square, you have 1/2 square, always. And this sign will come down to here, and this would be -2 plus 4, which is 2. And now square rooting, we know what to do now. We just did that. Equals square root of 2 plus or minus. X plus 2 equals plus or minus root 2. And there's my answer. We're going to practice a lot of this, okay? I know it's kind of confusing at first, but with practice we will get this, I promise. So I'm going to say solve by completing the square, and I'm going to show you several examples. Completing the square, which will solve any quadratic equation, no restrictions. So the first one, x squared plus 6x plus 5 equals 0. Now you need to notice this one, we don't really need completing square. We could do factoring, but we're going to complete the square just for practical reasons, because product of 5 and sum of 6, it's 5 and 1. You could do this in 2 steps. X equals -5, x equals -1, and you're done. Okay, but we're going to practice completing the square, and you'll see we'll get these answers by completing the square. Just practice it. Okay, so move the 5 over. X squared plus 6x equals -5. Make sure this is a 1, and then take that number in front of x, which is 6, divided by 2, and square it. Don't forget, divide then square, divide then square. So add, always add, not subtract. Add that number to both sides of the equation. That's 3 and 3, so x plus, remember what I said, plus 3 square, 3 square, that's a 4. Square root it. X plus 3. Now the square root is going to go away, and that's how we know we could have factored that. Okay, plus or minus 2, subtract the 3, -3. Since we don't have a square root, we want to finish -3 plus 2 and -3 minus 2, which we knew the answers are going to be -1 and -5 per factoring. Okay, it gets more complicated than this, but we'll get to that. Minus 10x plus 3 equals 0. Again, complete square. So we're going to move the 3 over. And then we're going to take that number. Usually I leave the sign alone when I square because it's going to be positive regardless. Okay? So 10 divided by 2 is 5. Even if it was -5, when you square it, it's positive. Okay? That's why I leave it alone. 5 squared is 25. So we're going to add 25 here, 25 there, and don't forget to add 25 to the right side of the equation. It's a balance. You want to keep the balance of the equation. So x minus 5 squared. You don't even have to think about that. That's 22 plus or minus x minus 5 is plus or minus root 22. Add the 5. X is 5 plus or minus root 22. Okay. Now it's not always gonna be an even number dividing by 2. It could be an odd number. Okay. What was that? 2, number 3. X squared minus 3x plus 1 equals 0. So move the 1 over and take the 3 divided by 2, you get 3 halves. Square it, you get 9 over 4. So take that number divided by 2, 3 halves, square it, you get positive 9 over 4. And you're going to add 9 over 4 to the left side and 9 over 4 to the right side of the equal sign. So we bring the x down, we bring the sign down, and then we look over here. 3 over 2 squared equals, to add these numbers, we get a times the first fraction by 4 to get the same denominator. So you get negative 4 plus 9 all over 4, which is 5 over 4. Now it's time to square root. Don't forget the plus and minus. X minus 3 halves plus or minus root 5 over root 4, but root 4 is 2. Add the 3 halves. So we get 3 halves plus or minus root 5 over 2. We got the answer. Okay, here's another one. So this was number 3, number 4, 3x squared minus 5x plus 1 equals 0. And again, solve by completing the square. So we move the 1 over, we get negative 1. Now we have a 3 in front of x squared. So we gotta divide it out before we proceed. So it looks like a little more complicated than all the other ones. So we get x squared minus 5/3 equals negative 1/3. Okay, move the 1, divide the 3. Now we take the 5/3 and divide it by 2, which is timesing it by 1/2, timesing by the reciprocal, which is 5 times 1, 3 times 2. And don't forget the squaring part. Divide, then square, which is 25 over 36. So plus 25 over 36, that's 25 over 36. Alright, again, the trick. X minus 5 over 6 square equals, to add these two, we get a times the first fraction by 12 to get 36 at the bottom. So we get negative 12 plus 25 all over 36, which is 13 over 36. Square rooted, x minus 5/6 equals plus or minus root 13 over root 36, which is 6. Add 5/6, and there's the answer. Okay. Well, there's a couple of there for you to try out. So my next one that I want to do, and last one actually, is number 5. 4x squared plus 2x plus 5 equals 0. So move the 5 over, becomes negative 5. Divide the 4. We get x squared. 2 quarters is 1/2, and this is negative 5 quarters. Okay, so over here, the 1/2 is divided by 2. It's like timesing it by 1/2, which is 1 times 1, 2 times 2 is 4. We only divided, we still have to square. 1 squared is 1, 4 squared is 16. That's what we're going to add to the left side and the right side of the equation. So x plus 1/4 squared, don't forget that, equals, you times this by 4 to get 16 at the bottom, so you get negative 20 plus 1 over 16, negative 19 over 16. And when we have a negative and we square root, we get I, right? plus or minus I root 19 over root 16, which is 4. So minus the 1/4, and we get 2 imaginary solutions. And that's solving by factoring, square rooting, and completing the square in 10.1. We're done with that. We're going to do the quadratic formula in 10.2.